Hey there.
Hi.
I haven't shared my screen yet. Let me do that. Yeah, I'm recording this session, KG. Is that okay?
Yeah, no problem.
Okay. Hi, Rob. Hi, Flora. Hi, Yael. I happen to know all three of you. So welcome.
Hi, good evening.
Good evening. I'm about to share my screen. I'll go off and do that. Hi, Annalisa.
Good morning, Prof.
Good morning. Good evening. Good night, whichever. Nighttime for me, midnight.
Yeah, no, it's early morning here at 9 o'clock. We had a huge thunderstorm last night, so it's lovely that your timing zone is so convenient for us.
Are you in Pretoria?
Yes, I am.
Okay.
And been working on O-C analysis the whole week, so I'm a bit tired of that, but we'll change gears in the coming week.
Good, good. I'm giving a virtual talk at the Ghana Planetarium in Accra on my time Saturday morning. I think it's Saturday evening over there at that time. I'm just trying to get ready to share my screen. I haven't been able to do that yet. Just a moment. There we go. The system is asking me for a password for firewall authentication. Let me see if what I'm typing works. No, it doesn't.
Do you have the...
I was able to log in just a week ago using VNC on DEIMOS, but it didn't ask me for authentication at that time.
Well, we are definitely on DEIMOS 3.
Yep. It's not that. It's the before the Wombat 1 password. There's another password that it had me type. It's asking for. I'm going to see if I have something like that.
Let me see if Percy is around. He might be able to help troubleshoot.
Thank you very much.
He's run out to get coffee, so.
No problem. What are you guys observing tonight?
Right now we are looking at an FRB field of the highest redshift confirmed FRB at the moment.
I think we took some images of it in September.
Yes, and there has been a redshift since then in the paper written up. But we're like the current targets are the foreground galaxies. Although under current conditions, I think the data is going to be very useful.
See. Right, tonight you're getting a spectrum.
No, we're trying to get spectra of the foreground galaxies.
Oh, I see.
Yeah, and I guess I can while you're trying to connect, I might share. So this is a webcam of the conditions right now, which are not very fantastic.
No.
So even though you can see stars in the image, for the clouds are going to be blocking enough light that for faint galaxies, they are not going to get a lot of signal, not a lot of signals coming through.
I see. Are you doing some kind of backup program then?
No, we're just we're just pounding away on our regular targets and see what's going on and see what we get in the end.
The clouds are not so bad that you can't guide the telescope.
Yeah, it's thin enough that we can guide.
Thin to guide, okay. Yeah, I'm basically waiting for the password without which I can't start up VNC.
Can you describe which? So this is the VNC password, or
it's the no, it's the what? Let's see, what is it saying? Just to give me a moment. It is saying password for firewall authentication.
Password for firewall authentication. Let me call Percy.
Yeah, Prajito.
Hey, Raja.
Hi, Percy. This is KG here. So Raja is trying to connect into the VNC for his outreach event. And he's being asked for a firewall authentication password for the VNC. Do you know what that is? Yeah. Yeah. Okay. All right. Okay. So Percy says that there shouldn't be, you shouldn't be asked for a password.
I know. I wasn't asked for one. Same computer. I wasn't asked for one last week.
I guess what we might be able to do, I don't know whether it is going to work that well, is to just turn my laptop around to point at the screen.
Sure. That would be great. Thank you.
Are we beginning or are we starting the session already?
No, it's recording. We've started it already.
Okay. So shall I give the tour?
Please, that would be lovely. Thank you.
Okay, so yeah. So first of all, I should introduce myself. My name is Keegan Lee. Everyone calls me KG. I am an assistant professor at the University of Tokyo, and I am one of the observers tonight. So we are observing in shifts. Well, usually observers will take the whole. Often you will just have one observer taking care of the whole observations for multiple nights. But these days with remote observing and whatnot, it can be convenient to have people in different time zones take over different parts. Hold on, I'm getting a call. Yeah, hi. Yeah. He's not registered. I don't think Raja is registered as an observer tonight. Okay. Is there something you can fix when you get back, or? Okay. Yeah, okay, no worries. Okay, all right, thanks. So anyway, so I guess one of the other observers is Sunil, who is in Santa Cruz, which is 3 hours ahead. So I'm taking basically the middle of the night shift so that he can, get some rest at 11 p.m. and come back at 6 a.m. At which point I will go to bed without having to wait until dawn. So what you're looking at now is basically the control terminal for the DEIMOS spectrograph, which is basically the instrument that collects the photons of the objects that we're trying to see. So the way it works at Keck is that the telescope is controlled by a telescope operator who is usually on the mountain, although these days sometimes they may not actually be in the mountain and actually be in the same room as we are. But the telescope operator is responsible for actually controlling the telescope. So the observer would tell the telescope operator where to point, and basically the telescope operator is responsible for the well-being of the telescope, because observers we're not you're usually not that experienced at using the telescope, and so if given full control of the telescope, we might do stupid things to it. So the telescope operator will make sure we do not do stupid things with the telescope, like pointing at the sun. So what the observer does do is basically plan the sequence of observations depending on the scientific program, and the observer also controls the scientific instrument. So that's the instrument which actually collects the light from whatever you're observing, and usually there's multiple settings depending on what you're trying to do with the science. So the controls that you see here are actually the controlling the instrument, which in this case is a spectrograph, which controls which collects light and disperses it into its different components. So the main action is in this window here, which is the where we actually set the different parts of the, you can see it is pointing at, yes, it is this terminal. If you go to full screen, you should be able to see my mouse. So this is where we control the various settings of the spectrograph. And then, we might click expose. So, typically, for example, right now we've been sitting on the same set of galaxies for about an hour and a half now. And we are about to finish in the next minute or so on this field. And so the next window over, which is, I think you are looking at it. So this is the basically a look at the raw data. So this might not look very pretty, but it is what we get. And these are actually, each of this is a rainbow of a distant galaxy. And the lines that we see are coming from our atmosphere. So hold on. So let me talk to Percy. So Raja is trying to connect to VNC. Sorry, we're gonna have to interrupt this while we trouble fix. Yeah. So Raja, could you describe your?
Yeah, Raja. So we're gonna kill you, but I'm gonna go ahead and try to add you as an observer for tonight. So maybe that'll help. Okay.
He might have stepped away.
Okay. I'll be
okay. Okay. So again, so basically, again, so this is kind of the data that we are getting right now. And hold on while I, so we've now finished our observations on the current objects, and I have to change we have to go to a new target. So excuse me while I do that, and I will try to talk through what I'm doing.
Readout complete.
Julie, we are ready to switch to the next target, and which I've highlighted. And be aware that I'm going to be unusually verbose because we're doing a Zoom outreach event, and I'm kind of describing to people what we're doing. So Julie here is our telescope operator. She is in charge of a $100 million, not quite $100 million telescope. It's certainly very expensive. So I've told her which our next target is, and she's gonna make the telescope move over to the new field. So the telescope does take time to move over. So, if you can see this, this is the so-called guide camera, which the telescope uses to fix itself on a particular set of coordinates, usually by fixing on bright stars. And right now
So a few seconds ago, you probably saw streaks as the telescope moved across the sky, but now it's settled on near where we are observing. Julie, I haven't changed anything yet. Could we do a Myra near this?
Yeah, sure. Do you want to do it right here, this, or do you want to do it a little bit over?
Let's see, we're gonna hang on this for a few hours. So
Maybe like an hour or two over?
yeah, maybe an hour or two.
Okay, I'll let you know when it's done.
Okay. Can I change the spectrograph settings right now, or do you need? Okay, thanks. So basically, Julie is now gonna focus the telescope. So for those of you who have used a regular camera or even a pair of binoculars, you've probably had to focus your eyepiece or whatever. In this case, we are doing something called a procedure called a Myra. So Keck is composed of the telescope itself is composed of a large number of individual segments, and each segment reflects its own image. And the procedure of Myra is to make sure that all of these images are focused on the same point. So in a second, you'll see this procedure. And in the meantime, because we always try to multitask to be efficient, I am changing a few things with the spectrograph to switch over to the next target. So apply this. Sleeping while I need to check my document. So typically each set of scientific targets will typically have its own instrument setup. So for example, depending on how distant, depending on where the targets are, they might you might want to be looking at different parts of the spectrum, etc. So we are doing.
Are you done with the instrument? Can I take over?
Yeah, take over.
Okay, do the rest of your end.
Okay. Okay, so where is this? So again, this is the screen that shows the actual raw data that has just been obtained. And in a few seconds, we'll see the focus images. So basically, the procedure will involve taking images as the different segments are moved slightly, and eventually it will try to find it'll try to find the ideal arrangement for the different petals to focus into a single image.
CCD readout complete.
So where's my screen over here? zoom out. Here we go. So, so this is an image of what it looks like if your telescope, this particular telescope, is not focused. So it's looking at a bright star, and instead of just the image of one star right now, it's reflecting back multiple images from the individual mirror segments. So so the goal is to try and make all those points focus into one. And so it's taking another image.
Is that a Myra that they're doing?
We're doing a Myra right now.
Okay.
So yeah, Raja, Percy just added you to the users for tonight, so you might want to try the VNC again.
Thank you. I will do that.
So for so the computer, you've heard the computer say exposure complete, and then after some seconds there it says again CCD readout complete. So I think those of us who are a little bit older will remember in the first generation of digital cameras, if you take a picture with the digital camera, it actually takes a few seconds before the image shows up. And that's because the first generation of digital cameras were using basically the same detectors as most astronomical instruments, which are called charge coupled devices. So it does take some, especially for the large detectors that we have these days, it takes a while to read out. And of course, these days, most consumer digital cameras use so-called CMOS detectors, which are much faster. So we're now done with that sequence, and actually there's
So we got 1.2 arc seconds for the full width half max again.
okay, thanks.
Move into your target, guiding into this pocket.
Thank you. Right, so this is the guider camera, and as I mentioned earlier, right now it looks like a bunch of streaks as the telescope moves across the sky to get back to our original science target. So the guide camera is a small camera that's pointing at a it's not directly looking at the sky, is it? Right, so it's looking at a part of the instrument that reflects back. So it does look at the sky directly, and it takes like 1 second exposures. So now we are at the science target again, and I have to begin something called slit mask alignment. So I'll explain once I'm done. Okay, so
Okay, we're ready.
thank you. So we're doing something called alignment, which is basically the fact that as wonderful a piece of engineering that the Keck telescope is, we're still trying to point very precisely on the sky after moving halfway, so you imagine trying to point very, very accurately as something that's very at a very accurate position on the sky, and typically there needs to be some sort of feedback mechanism to accurately position ourselves on the sky, and this is called a slit mask alignment.
KJ, I'm sharing my screen now.
Okay, that's so you can show the SAT.
Oh, should I show the slide? Okay.
Yeah.
There we go. Control 2.
So our program tonight is to take spectra of distant galaxies, which is basically taking a real rainbow for all these galaxies. But first, we need to position ourselves correctly on the sky. And after I'm done with this, I will explain a little bit what that does.
Exposure complete. DCD readout complete. Exposure complete. DCD readout complete.
Oh, okay. So everything's a little bit more difficult tonight because it's cloudy. So if you look at, yeah, oh, we lost the guy star. Okay. So basically,
Exposure complete.
so if you look at me, this piece of metal that I'm looking up, that I'm holding up is it's called a slit mask. And basically what it does is that we use this, and you can, if you look here, you can see these individual slits, and this piece of metal.
DCD readout complete.
And this actually allows us to select the positions of the galaxies that we want to look at. And so basically, this is actually the size of the image that the telescope sends to the instrument. And basically, before we start taking our science exposures, we have to make sure that like these slits are correctly lined up with the galaxies that we actually want to observe. So what we do is we also have to drill individual little holes that are here, and these little holes are going to be at positions of bright stars. So once we move our telescope to near the position of where we think we want to be, we'll first take an image through this, and then we'll take a few images to make sure that the stars are lined up within in the middle of these holes before we begin observing. So that was the procedure that I was trying to do just now, which is not quite working right now because it is cloudy again. So unfortunately, we are gonna just wait until it clears up a little bit.
So we're gonna wait here until it comes back.
Yeah, let me know if we get guiding back.
Okay, I'll be right back.
Thanks. So I guess okay, so I guess we had some questions, and now that we're clouded out, I will try to go through the list of questions. So Rob Johnson was asking about FRBs. So FRBs are a new class of objects that were basically discovered as extremely fast radio signals that were detected in the sky. And in the past years, we've been able to confirm that these guys do come from galaxies, and in some cases we have been able to identify them to individual galaxies. So that has allowed us to be able to study what kind of things might cause fast radio bursts. I think the current theories are somehow neutron stars are probably binary neutron stars are doing things to each other's magnetic fields, but it's still not clear yet. But one of the things we can do also with fast radio bursts is use them to probe the gas in the foreground, and in this particular case, we are trying to identify galaxies that are near the that might have gas that is being intersected by the fast radio burst. So that's the science goal that we are trying to do tonight. So Jamaica was asking, how is the weather affecting the observations? Right now it's cloudy, so sometimes with very thin clouds and with relatively bright targets, we might just push through and try to take data. But tonight our targets are relatively faint. And right now it's cloudy enough that we cannot even guide the telescope. So typically, as I mentioned earlier, a telescope the telescope needs to see some bright stars near our observing field to kind of lock itself to the same position. And right now it's too cloudy for even that. So Aparajito, I'm not sure if I'm getting your Aparajito. I'm sorry, I'm getting your
Yeah, that's right.
Yeah.
It's Operator. Yeah.
So what mass did you think were going to be B-shaped?
Okay, so the one you just showed, the one you held up to the camera, that one. I mean, I remember there's like a curve on one of the edges. Yeah. I mean, to my left, and to your right, I think that side, I remember being curved in some of the photos. Yeah, I mean, not on the corners, but like right in the middle, if you know what I mean. I mean, I actually haven't seen a mask, on camera, so that's why I'm confused. I just saw some diagrams, so yeah, that's why I'm trying to put two and two together.
I can't remember what this notch is for. It's Percy here. Percy's our support astronomer. Raja might know better. Raja, are you on? And if you are, do you remember what this notch is for?
I can't see. Let me just bring up my video. That's the only thing I can't see right now. Just give me a moment. I'll be able to. So let's see.
Basically the one corner is cut off on the DEIMOS mass.
Oh yeah. So why it's cut off, I don't remember, but that part doesn't see any light anyway. It's vignetted. Okay. Both corners are vignetted. One side the corner is cut off. The other side the corner does not contain any slits.
All right.
Oh right. And Raja, I remember seeing in your proposal, the masks are kind of B-shaped. So your recent proposal, that's what I'm talking about. So I don't see that shape here. So that was my question.
When you say here, you mean on the metal plate?
Yeah, that's right.
Yeah, if you look at the region over which the slits appear, it's shaped like a capital letter B, even on that metal plate.
I see. So it's not the metal plate that's shaped that way, it's just the distribution of the slits.
Exactly, the area of the slit, the area of the focal plane that in which one can place slits.
Oh, okay, got it.
There's a one-to-one mapping from sky position to position on the plate because the mask is placed at the focal plane of the telescope.
I see.
So the alignment is done then, and that means an exposure is going on.
I see guide stars again, so I'm trying the alignment again.
Okay. Oh, okay.
We were not aligned before.
Got it.
So
exposure complete.
There's a question from A. Just. Let's thought the slits were fixed and move around object to object. So basically, depending on the objects that you want to see, we do prepare multiple of these slit masks. So DEIMOS, I believe, has 8 slots for these.
CCD readout complete.
And so basically we do have to prepare this slit mask in advance of our observations. There are some newer instruments on other telescopes where the light doesn't go down a slit mask, it goes into optical fibers, and those optical fibers can be moved around by little robots during the night. But DEIMOS is it's a bit more old school, and we do have to prepare these metal plates.
And KG, I think MOSFire has configurable slits also.
Yeah, so MOSFire, which is another instrument on Keck, also has it does it in a slightly different way. So it has kind of bars along the side that kind of slides along to provide the slit. But as I said, DEIMOS is a bit more old school. So I think we are not. It is clear enough to align, and I'm doing the sequence now.
You said it is clear enough to align?
I'm seeing light through the boxes.
Yeah,
so
I saw that. I saw that.
I'm not sure what's wrong with star 1, but I'll remove that from the analysis. I'm on mass 2. I need to change.
Exposure complete.
Let's resume. LST is around midnight.
DCD readout complete.
Oh, it looks like the stars have reappeared a bit.
Yeah, I've been
Kind of faint, though.
yeah, I'm trying to, I'm attempting to find the line again.
Okay, it started getting.
Okay, so if you were looking at that alignment, so basically what this software does is that it looks at the position of those stars within the boxes, and it tells the telescope to move around until as many of these stars are in the middle of their boxes as possible. So if you look at where my mouse is, it's telling us how far away from the center of, well, it's telling us the amount of movement that the telescope should move to center the stars. And right now it looks like the values are very small, which means that most of the stars are inside the boxes. So I am going to declare that we are now aligned. Just in time for clouds. Just in time for clouds to roll in. So I'm gonna. Well, it's kind of popping in and out. The clouds are kind of moving in and out. So. So, Julie, we are not able to guide right now. Is that correct?
It's coming and going kind of fast. It looks like.
Okay.
I'll trying again right now because it came back, but I saw it dim again after that. So.
But basically, I think we've done with final line. So you could probably mark base if that makes sense right now.
Okay, I raised the exposure time. If you want to maybe check the final alignment one last time, and then if it holds through that.
Okay, sure, I can do that.
Just because I'm using guiding and all.
Exposure complete. DCD readout complete.
So we're just double checking the final line because the clouds might be. Okay, this is distance. So one thing clouds do is it scatters light around a little bit, so makes things a little bit, well, it literally does make things fuzzier. So we are attempting the fine alignment again.
Exposure complete. DCD readout complete.
Yeah, it's too cloudy to even confirm that fine alignment.
That's answering Jamaica's question on the chat. Is that what you were doing?
That was kind of what we were doing. I mean, I was just trying to confirm whether that fine alignment was even correct. But you know, this latest exposure doesn't even give sample numbers at all. So I mean, so if you look at the so again, this so ignoring this first one, which looks like something's wrong here, but basically, so this is the boxes. So these are X and Y axis of each of the star boxes, and typically we want to see like a kind of pointy signal that goes through each of these boxes so that we can measure their position. Instead, we're looking at this blob, which is which is basically the signal from the clouds. So right now we're not getting. So if you can look, so here, for example, you can see just kind of a bit of the star that's peeking out through the clouds. I
guess you can see it in star 1, star 2, little hint in star 3, star 4, even 5. You can see a hint of a peak all the way in each of them. 6.
But it is difficult to measure a precise position in this case.
So I have some 12th magnitude targets in case you guys are looking for something to observe. These are RLRI that we are monitoring.
Okay.
But I first want to check if you have LVM slits loaded in your. Let me see. Do you mind if I turn my if I go to non-view only mode?
Yeah, we do have LVM loaded.
You have LVM loaded. Yes. Okay, if you're interested, I can send this to you. The 12 magnitude objects, we probably will want, I don't know how bad the clouds are, but we don't care about photometry. We just care about radial velocity variations of the RLRI as they pulse. So we're doing time series spectroscopy. Actually, one of the people on the Zoom chat, Yael, is a high school student who's been working with us on this.
Mm-hmm.
But of course, I don't want to disrupt your observations in any way.
I would say, yeah, please. I assume this the correctly formatted star list.
It's not in the star list, actually. Yeah, it's formatted for the star list.
Right. So if you can email me the star list,
I'll do that right away.
The setup you would like.
Are you using 600 ZD? Okay, so we would probably want to go to the narrowest. We want to put it on the narrowest of the slits of LVM slits, the half arc second slit.
Okay, so
I'll email you. In the meantime, I'll stop sharing my screen for a moment so I can email it to you.
Sure.
Now I can see everyone's, at least their Zoom profiles. Hi, Jamika. Hi, Annalisa. And Rob, Yael, Aparajito.
Aloha, Raja. Aloha.
Aloha. I will quickly send KG the star list that I have. KG, I'm going to use the same thread in which I sent you the Zoom link.
okay.
I'm sorry, Raja, could you explain what's about to happen now? Are you about to observe something different?
Yeah, because there are clouds, we're just going to observe bright stars.
Ah, okay.
In
Yeah,
fact, this time.
Raja. Yeah,
Sorry. Go ahead.
Raja is studying the Milky Way, which means he's looking at there are stars that are bright enough to be observed even under current conditions.
And the ones I'm sending you are ones we normally observe around twilight when the
Mhm.
sky is not completely dark, just as this is sort of a secondary filler science program to monitor RLRA. But so when there are clouds, it's a different kind of non-optimal condition compared to when there's sunlight in the sky. But in both cases, we're sort of limited to very bright stars, and that's what these are, the 12th magnitude.
Okay, so we're getting the guiding alignment not go well.
Yeah, we could not align.
Couldn't
No.
finish the alignment.
We couldn't finish alignment.
Yeah.
So
Stop. Guiding work.
okay. So basically, Raja's gonna send me a list of bright stars that we could probably observe on even under current conditions. Could I forward you that star list and could you add it to the system? Or do I have to go through my observer?
I mean, I think that
It might be easiest.
really made it.
Should I just send you the coordinates?
No, he's gonna send us the star list, the formatted. It might be, Raja, it might be easiest if you just tell us the directory your star list is in.
Oh, absolutely. So it is in under my name, P. Guha Thakurta.
So P.
I'll put it in the chat. I'll put the name in the chat.
Okay, yeah. So you just open up the star list and we'll point you to the correct one.
So on the Keck, I uploaded via the Keck web interface a couple of weeks ago. So that's the name. And I think the last time I uploaded something, it would have been, the date would have been October, UT date would have been October 19th. I'll put that date in the chat.
Okay. So Julie, go to /starlist/
P. Guha Thakurta.
PGUHA THAKURTA. Just hitting tab should probably work.
I'm sorry, what was the last name?
So it's
P. Guha Thakurta. Yeah, sorry.
PGUHA.
Yeah, and I hit tab, that should bring up something.
Yeah, my Keck Observer login name, username is PGUHATHAKURTA. It's my, I put it in the chat, but I don't know if you can see the
Yeah, I
chat
saw that.
actually.
In the web directory.
Yeah,
You are.
and it's something for 2022 October 19. Is there one that looks like it's for that date?
To October
19. Yeah.
Okay, added it to the enter your star list.
Okay, thank you very much.
Perfect. Thank you so much.
Star list again
Thanks.
to see it.
So I need to refresh my star list.
You know what the long sleep?
We are probably going to switch to long step. So
I was just looking at the star list, starting with target 11. I'm pretty sure your own star list is wrong, incorrect format. For example, target number 11 says equinox 48.1. If you want to go to any of those shade stars.
I see that. Is that from the My Star list or is it from something
I
else?
think there might be. Does yours start with J073802, for example?
I don't think so, but let me double check because just
Yeah, there's definitely off because
something is off here.
yeah.
Why don't I do this? Since there's one object, can I put the RA deck in the chat?
Starting at object 61.
Say again, Raja.
Since it says since there's one object, can I just put it in the chat? Literally a single object.
Okay, it's tricky because I don't have yeah, so
I
it's
can
just
read it out to I can read it out to Julie.
Okay. Julie, can you slew to a specific coordinate? Which Raja is gonna read out the RAN deck.
Sure, or if it's a standard star, I can resolve from the name.
It's not a standard star, unfortunately.
Okay.
So whenever you're ready, I can read it out.
Yeah, go ahead, Raja.
It's 0041.
0041.
Yes, 19.44.
19.44.
Yes, and then +5, 05, plus 05, 20,
Okay.
46.20, and then 46.8 for the seconds of declination.
46.8.
And Vic, how can I give you the name of the target? I can put it into the, actually I can put it into the object name field if I can get out of view only mode for a second.
Yeah, go ahead. Raja is gonna fill it into the object name on the instrument GUI.
It's PS1_233932.
So it's PS1 underscore 233932.
What was that? TS1 underscore?
PS1 as in Penn stars. PS1 underscore 233932.
233932.
Yeah.
Should I load LVM slits for this?
Do you need a PA for it?
Parallactic.
Parallactic?
And we'll take something like, I don't know, because of the cloud, something like a 10-minute exposure.
Sure.
Again, please stop it if things are getting better and you can.
Yeah, sure.
So that one was in the star list.
It was?
But
Okay.
yeah, it's number 65.
Okay.
Okay, so did you want me to go there now?
Yeah, we're gonna go do LVM on the narrowest slit.
I just loaded I put LVM slit into the slit mask.
Yeah, I saw that.
You're in 0th order right now, it looks like. The wavelength is 1098.
Yeah, we're on the mirror, yes. Because we were at the
Having trouble finding their offset stars.
it's the conditions are actually bad enough that we might not even be able to see 12 magnitude.
No problem, of
Yeah,
course.
but
You know how bright this actually
It's
is.
a 12th magnitude star.
yeah, it's a 12 mag star. So if we can't see it, then
It's hopeless, yeah. No.
Yeah.
What central wavelength are you using when you're in spectroscopy mode?
We are currently on 7500.
7500, okay.
You want it on the smallest 0.7 arcsecond split?
Yes, please.
Isn't the smallest 0.5?
Is there a 0.5 slit?
I don't think so. Looks like 7.8, 1.0, 1.2, and 1.5.
Yeah, 0.7 is the narrowest.
Okay, let's do that then. Should I put in 7500 for the grating tilt or?
Yeah, sure. For the wavelength, yeah.
And you're using OG 550, I see.
We're using OG 550.
Got it. Should I put it in then?
Yeah, please go ahead.
7500, right? I've just put that in. I assume you have an FCS set up for this.
Would that be easier for you guys?
We might have to go back.
Bottom.
We might have to go back to the original science target, so it's fine as it is.
I'm going to get out of view. I'm going to go back into view only mode if that's okay.
Sure. Yeah, right now we are definitely, it's definitely too cloudy to do anything.
Too bad.
So for those of you who are curious about what the sky looks like right now, I just put a link to a web camera on another telescope that's kind of looking at the sky. And if you click on the link, you'll see that it is not great for astronomy right now.
And
Hold on.
sorry, KG, go ahead.
Julie, are we actually able to guide right now or no?
Well, I see the target, so
Okay.
let me put it on split and we'll see where we are.
Okay.
Do you have a sense of what the seeing is tonight?
Myra has been giving 1.2 arc seconds.
I see.
That was when the clouds were a bit thinner than right now.
And the reason I'm going with the narrowest slit is to maximize spectral resolution.
Sure.
I can see the star in the slit now.
Yeah.
Actually getting a lot of signal. So I think 10 minutes is way too long. I would start with a 1 minute exposure just to see just to gauge the signal level.
Okay, so where are we now? Exposure.
And Jamika was, you were asking what parallactic is. I'll explain in a moment once we start the exposure.
Okay, thank you.
So let's, Julie, let me know when we are guiding.
So I saw it there and it just disappeared and we're at a 5-second exposure time.
Okay, yeah, let us know when it's back on.
Okay, we're guiding on the slit.
Okay, so I am gonna expose. So we're doing, sure. So 60-second exposures.
It's looking quite faint now, KG, so maybe 2 minutes, but might be better.
Okay. Sure.
Thank you.
So LVM 0.7, 600 grading.
All looks good to me.
500 and on 550 filter, 120 seconds exposure.
Is FCS tracking by any chance?
It's been finicky, but I believe it is tracking.
It's giving, I see a warning for some reason.
We've been told by Percy to ignore the warning sound.
Got you. Okay.
Yeah.
It. Okay. Looks good. Thank you.
Okay, so we are exposing.
So ultimately it is in the star list, right? This one?
It is a current, yeah, it is apparently on the star list.
There it is.
It's indeed it is, yes.
Yeah, it's number row 65.
Yeah.
Since we are monitoring these RLRE, there are actually 3 stars that are visible at this time of the night. The other 2 are not the 2 immediately above in row 63, 64, but they're actually in slightly lower rows. I think in row like 70 or so. If you scroll down just a little bit more,
sure,
it'd be possible to see. I don't see, oh yeah, there they are. So I see 233932 again, same object.
Yeah, I think Julie just added that.
Oh, I see. And then below that, is there anything else?
No, that's the bottom of the list.
Okay, so, oh, I know why. We had the first half of the night. That's why the others are not loaded. Okay, I have two others that I can email you. But
Sure.
if there's only again, if if you're not doing anything else, please at any moment you should go back to your science, because
Yeah.
right now it's not looking bad on your screen. I mean, the LiDAR screen, it's picking up faint stars.
Exposure complete.
But of course, the way the clouds are, certain patches of the sky I bet are clear, some other parts are not.
Yeah.
So we should be able to see the spectrum appear in the control 1.
Yes.
As soon as the readout is finished, it's reading out. It's about half done reading out. I see that the ADAP team is listed as the observers tonight. Dusty and Deborah.
Yeah, basically they've been
After the
listed as
workshop.
observers so that they can stay in the VSQ.
Oh, I see. Okay.
DCD readout complete.
Okay, so
if you want me to play with the cuts, I'm happy to do it.
Go for it.
Okay, I'll just unmute. I'll just go back to. What's the word for it? I'll go to non-view only mode. There we go. There's the star. And one of the cool things about the star is, okay, that's the OG 550 cutting it off. Let me see if I could spot the H alpha line in the star. Let's see. You see the H alpha line right here? I'm going to zoom in a little bit. I don't know if people can see the H alpha absorption line in the star. I'm just zooming out. So if I'm reading this correctly, the y coordinate is about 880 over here. And then up here it is 2670. So 2670 minus 880 is 1790. I multiply that by the pixel scale, which is 0.67 angstroms per pixel. And I get an offset of 1199. So I add that to OG 550, which is 5500 plus this. Yeah, so 6700. So this is very approximate, of course. So what I'm convinced that this line in the center of the frame is H alpha. And I'm zooming in so you can see this absorption line in the star. So it would be great to get, a sequence of these 2-minute exposures, if that's okay. KG, if you set up a sequence of these in the you are taking another one. Fantastic. Thank you. But that's H alpha. I don't know what this line is over here. But we should be able to see the calcium triplet also. Oh, there's the other calcium line.
Exposure complete.
Yael, can you see the calcium triplet? This is one of the lines. This is another line. It's the calcium triplet line right there.
DCD readout complete.
Wow. This was much fainter. This was affected by clouds big time.
Mhm.
So I'm thinking maybe go a little longer, please. Maybe 5 minutes. Sure.
Oh, sorry. Well, let's do.
Yeah, 5 would be better probably, yeah. Because so there's lots of clouds because it varied a lot between 1-2 minute exposure and the next.
Mhm.
The apparent intensity.
It looks like our 1292 star has disappeared.
It's another patch of clouds has moved in. So
Yeah, can't see it at all.
Just sit here and wait for it to come back.
We're just gonna continue exposure.
Is it possible to mark base?
Julie, could you mark base actually? Or wait for it to pop up in the guide.
Yeah, maybe wait for it to pop up and then mark base. Now, Aparajita, I don't think MOSFire has a fluxure compensation system. I think DEIMOS does, but not.
MOSFER is like the infrared cousin to DEIMOS, right?
Yeah, I don't know if it has a
Yeah.
fluxure compensation system, does it?
I think it does. I mean, I asked in the last STS session. They were observing on MOSFER.
Got you.
Yeah.
Okay, let's go back to those lines. You know, in the next 5 minute exposure, I don't think we'll see it because the clouds have completely obliterated. Oh, now the star is back. So maybe we'll see it in this next exposure. Yeah, you can see the calcium triplet. You can see H alpha. Those are the main lines we can see with this wavelength setting because we can't see H beta because of the blocking filter of OG 550. But we can see the 65, 63 line, and we can see the calcium triplet line. Yeah, now suddenly it's the star is shining quite brightly. So Hopefully this 5-minute exposure will give us very good signal. It's about 3 minutes into it. Jamika, I'm looking forward to seeing you in person when I go to Hawaii in November.
I am too, Raja. Yeah, absolutely. Absolutely, for sure. How long are you here? Is it for
5 days. 5 days.
5
I'm arriving on the 16th, leaving on the 20th.
Okay, for sure. I'm positive that our paths will cross again very soon.
You know, and also because we are observing only first half nights, so it'll make for a less hectic schedule. So, you know, we'll go to bed at, you know, we'll be done with the observing at 12, you know, a little after midnight. So can do, you know, unlike full nights where really eats into the next morning, we won't have that.
Oh, okay, good. Well, I'm definitely looking forward to seeing you too, for sure.
Me too. Take care. Yeah.
Mahalo.
Interesting to see what this spectrum will show, because the clouds are certainly going in and out. Now it's disappeared. Now it's back.
What are we seeing in this top left picture, Raja? Is that, it looks like some kind of bright spots? Yeah.
This one, right? So these are, this is a custom slit mask with slits of different widths cut into a very shiny metal plate. That's what the M in LVM slit C stands for. You know, the name is LVM slit C. This stands for long, variable because of the different widths, M for mirror, slit, and this is the C version of it. There was an A and B before that. Sorry, my lights just went off in my own room, so I'm completely in the dark.
Exposure complete.
Okay, so it finished. Now it's going to read out. And then when we look at the spectrum, we should be able to see these absorption lines. You can see the readout here is it's reading up to it's got a third done. But this time when we look at the display, we should be able to see the thing pop out. The calcium triplet line should pop out here.
DCD readout complete.
Raja, I realize I don't actually know how to set multiple exposures on the current interface.
It is by, you know, you do it on the command line.
Okay.
Yeah, let's see. Any one of the windows.
Yep.
Yeah. So the command is GOI space, however many we want.
Okay. If with the current exposure time, right? So
it'll just use the current exposure time, exactly. And then anytime you kill that script, it'll stop the sequence. It won't kill the exposure. The current exposure will still keep going.
Okay. And then,
you see it started it, but if you were to kill it now, it'll only do one.
Okay.
That's how it works.
Stop it in
and then, yeah, basically you have to stop it in 2 places if you want to stop it.
Yep.
You control C out of the script, and then.
So the star is back and nice and bright.
Thanks.
Kind of thinking maybe I should just not guide though, so that I pull it off if I miss it when we lose it. So I can see that it's still tends to bring up and down a bit. Just while we were talking.
Sorry, I didn't catch. So you're suggesting not guiding, or?
Yeah, I'm just suggesting they just not guide. Because yeah, here it goes. It's disappearing right now.
So basically, with marked base, right? So basically, it should
the tracking should
The
be,
tracking's pretty good and
okay.
it's your brightest star.
Yeah, should be
Yeah,
fine.
it's not really, but
Okay, yeah,
for a
thanks.
star, okay,
Yeah, makes sense. Thanks.
still on the slit, so.
Yep.
Okay.
KG, you can see the sodium doublet so clearly in the middle of the, if you go to control, this is the sodium doublet from the sun,
Right.
from the air glow, I guess. These are from actually from micrometeorites striking the Earth's atmosphere. That's where the sodium comes from. So the
Oh.
same sodium that's used to create a laser spot, I guess.
Oh, I did not know that. It's the pain of the extragalactic observers that none of our targets are ever bright enough to be usable in
AO.
cloudy conditions.
Oh yeah.
Well,
Yes, that's
also,
true.
yeah, but,
It's true. So this cutoff over here in the spectrum, I'm guessing, is the OG 550
yeah, I'm pretty sure.
filter. And then there's H alpha right there. Let's see if I can spot it again. Right there. There's the absorption line, Jamaica and Aparajito. That's H alpha right there.
Okay. It looks really faint.
No, it is faint. On the other hand, there are a lot of pixels that all show this absorption. So when we stack it up, we have very high signal to noise measurement. Now, in this particular 5-minute exposure, the clouds were coming in and out. As we can see from this window, the star has almost disappeared in this 5-minute, for part of this 5-minute exposure. But then for part of it, it'll probably be back. And so we are sort of, this is why it's impossible to look at anything faint. This is 12th magnitude. In spite of that, it's coming and going because of clouds.
Okay.
So the original science targets that we were originally going to observe are
1,000 times fainter.
25th magnitude. So it's literally
1,000 times
10 to
fainter,
the
right?
power of, it's literally a billion times fainter than this star. No, it's more.
Not billion. Let's see. 12 and a half. Let's say 12 and a half magnitudes fainter. So 10 magnitudes would be 10 to the 4.
Yeah.
10 to the 5 times fainter.
Yeah.
100,000 times fainter.
100,000 times. I think once I was on, I used to be a Hubble fellow, and we have this Hubble symposium, and I think there was a chap who was looking at exoplanet radial velocities on 4th magnitude stars on Keck.
Wow.
And of
4th
course,
magnitude.
Yeah. And of course I'm doing my 24th magnitude galaxies. So that's a pretty big gap.
Which years were you a Hubble
Exposure
fellow, KG?
complete.
15 to 18.
I see.
Yeah.
I was a Hubble fellow from 1992 to 95. I actually stopped it in 90. I left after 1.5 years to take on a tenure track job, but
Wow.
many years ago. See, now the star is back while it's reading out. But I bet this exposure won't be very good, this one that's about to read out. My guess is,
DCD readout complete.
yeah, my guess is the continuum. Yeah, there we go. It's much fainter, but you can still see the H alpha. If you have the patience to get 2 other stars, I can put them in the, I don't know how to do it. I can send them in an email to you.
Okay.
And it should be properly formatted in the email.
Is this a confirmed absorption line?
Oh, hold on. Rob Johnson, yes, you are correct.
What was that? Sorry.
He was saying that 12.5 magnitude difference is 10 to the 5 difference of brightness, and yes.
This is what, yeah, I have to do this conversion for my intro astronomy class all the time.
Yeah,
so I have some practice.
the rule of thumb is 5 magnitudes is a factor of 100. That's my crutch.
Yes, yes. So 5 plus 5 plus 2.5. I just sent it to UKG. It's only got 3 lines in it, the star list, but it should be properly formatted.
Okay.
And it includes the one we're observing now and 2 more.
Okay.
Jamika, can I use this moment to explain parallactic?
Oh, yes, please. Thank you.
Okay. So what happens is, we're taking a spectrum, right? So we're getting light that's anywhere from sort of green or blue light all the way to red light. And these different wavelengths of light bend by different amounts when you're, let's say, going from air to glass or vacuum to air even. So the Earth's atmosphere acts as a lens or prism because it acts like a slab, because the starlight is coming from vacuum, which has a certain refractive index of 1.00 by definition, to air, which has a slightly higher refractive index. In other words, the speed of light is slightly lower in air than it is in vacuum. And this slowing down of light, the factor by which it slows down is different for different wavelengths of light. That's another way of saying blue light bends more than red light when it enters the atmosphere from vacuum. So when you're looking at a star that's directly overhead, there's no problem. But when you're looking at a star that's not directly overhead, the light from the star, the red and blue lights, land in different parts of the detector or on the different parts of the slit. So the slit is oriented along the direction in which the So sorry, let me back up. The Earth, in other words, the Earth's atmosphere produces a tiny little spectrum each time. So if we're trying to take a spectrum of the star, and if we align the slit with that, all colors of light fall within the slit. But if the slit is oriented at any other angle, then all colors of light don't fall within the slit. And that's what parallactic angle refers to, is the angle along which the Earth's atmosphere is producing a mini spectrum.
Ah, okay. I was thinking, and no, and that makes sense. I appreciate that really clear explanation, because I was thinking that it was related to parallax in some way.
Yeah, I don't know where, I was in fact wondering where the name comes from. It comes from parallel or parallax, I'm not sure.
Ah, that's a brand new word for me. Parallax.
Parallactic, yeah, with a double L because of the, as in parallax and parallels. Okay, so another one is about to read out. And let's see if the continuum gets brighter. That's a good measure of how bright.
Readout complete.
It got fainter. So this was clouds were bad. So it's doing the last one of three. It's doing the third one of three. This last one was so faint that I'm not sure we can get much from this, although I don't know. Maybe we will. I'm going to change the display a little bit and see how bad it really is. It's not too bad. You can still see a lot of continuum. I mean, plenty of continuum. So KG, if the clouds are still bad now, if it continues to be like this, do you have other backup targets you're going to go to, or are these RLRE useful for you?
I think I'm very happy to keep bashing on this RLRE for you.
Okay, so. Thank you. X and I were going to do a time trade because we observed his fast radio burst, but then most of that came from Alessandro Savino. I only did some on my night. I just did some photometric calibration.
I think this RLRE are gratis for you.
Thank you. No, but really at any moment, if you feel that there's something else you can do, you should just go back to. But this is maybe if nothing else, this is serving as a good cloud monitor, because from one 5-minute exposure to the next, it's changing quite a lot.
Suppose it's actually cloudy enough that I should go look for some solar system types who want to look at Jupiter.
Also, Jupiter is very bright in the sky right now, very bright.
Yes.
But even on this Guider image that we're looking at, that guide star keeps coming and going. I mean, right now, for example, I can't see the star in the slit, but a few seconds ago it was visible. It's pretty. Sorry, I'm not sharing my screen right now, but I will do that in a moment. KG, you're a pipette user, I assume.
I actually am not.
You're not, okay. I'm a pipette convert myself. I'm using pipette more and more. So when this reads out, we'll be able to see if this spectrum got brighter or not. See, the star is shining through really brightly now. It's very perverse. During the readout, it gets the clouds part. During the exposure, the clouds come back. Nearly done reading out.
CCD readout complete.
Wow, it keeps getting fainter.
Supposed to shoot.
I wonder if it's worth going to one of the other stars.
They're brighter or
There's similar brightness, just different part of the sky. And for the monitoring, it would help because RLRE don't change that much on, from within in half an hour. But so coming back to this later after going to the other two might be good. What's the best way?
Let me just put in another exposure while I.
Sure, that sounds good.
I've uploaded. Let me see. So the list you just sent me is it's not okay. It is a set of new targets apart from.
It's two new targets and the current
okay,
one.
all right. I'll ask Julie to load it.
Thank you.
Julie, could you load another little star list of mine? So my directory is star list / KHLEE.
Sorry, you want me to append it again, or? you
Yeah,
want me to
just append it.
Okay.
So my
Okay. This is
KHLEE, and there's a file called PS1_RRL.
PS1_RRL.
Yep.
So I think that started at number 75 or so.
Okay.
Anyway, you can map the Hawai'i star list again.
Yep.
At the bottom there, those three.
Sure, no problem. Okay, so yeah, we'll move over to one of the other guys.
Number 78 should be a bit more easily reachable than row 78 should be a little, index 78 should be a little easier to reach than 77. 77 is still 4 hours over.
Yeah, sure. Although that you are looking at a bit longer path through the clouds.
Yep, with the higher declination.
Yeah.
Yeah, true. Yeah, I'm running this. Where is it gone? I'm running these pipette jobs. Dusty's been helping me with that. Yeah, these two things that say running over here are my jobs. Been running for 8 hours, 7.5 hours. This is a single exposure you're running, KG, on this one?
Yeah, I was thinking, yeah, I'm just probably gonna slew over to the,
No, no
No.
problem. No, and now actually we're getting good signal because the star is actually quite visible in the slit.
I would probably, now that I think of it, there is sufficient, we're at air mass 1.04 right now, and I think the column of clouds is just about doable at this air mass, but I suspect going to air mass 1.5 or whatever is not gonna.
I see what you're saying. So you think it's better to just stay here?
Yeah, because it's 4 hours and.
Yeah, one of them is 4 hours, one of them is 3.5 hours. Maybe it's best to stay here. You're right. Let's just get a sequence here, and what you're doing is good.
Well.
Yeah, I mean, if the conditions persist, you have the whole night, right?
We do have the whole night.
Yeah, if the conditions are this bad and this one starts to set, the other ones will be coming up.
Yep.
I will soon, since we are at the 2 a.m. mark for me and 11 for you, I will stop the recording for the Shot of the Scientist session.
Exposure complete.
But what I did want to do, if once you start a sequence, I wanted to just introduce the few people who are on the call to you, because I know everyone.
Sure. Let me start the next.
Yeah, please go ahead. And I also want to, I'm watching the readout of this one also to see if it got brighter. Yeah, this is actually very close to overhead, right? As you point out, the mass is really low. All right, let's see if the star gets brighter on this readout.
DCD readout complete.
Oh, so much brighter. Look at that. Now you can really see the H alpha line. No, that's too much. The H alpha line is so clear. So Rob, if I have it correctly, you're at Huntington Beach. Jamaica, you're in Hilo. And Annalisa is in Pretoria in South Africa. Sorry, I look like a ghost myself because my lights are off in my room.
Well,
I'm
nice
actually
to meet you.
West San Fernando Valley.
Oh, West San Fernando Valley. Okay, sorry. Ventura?
No, not quite to Ventura. Still in Los Angeles.
Still in LA. Okay.
And yes, you're correct about me. I'm in Hilo. Well, I work in Hilo, but I actually live in Pahoa, just as HPP.
And Annalisa is based in Pretoria. You studied at UNISA, right? University of South Africa.
That's correct, Prof. I did a master's there, and I am exploring options how to take it forward. So right now I'm working still on something analyzing about 30 odd WUMA stars, their O-C analysis. I finished it last night, so I'm having to just see what the trends are from there onwards. Okay. And then, as I say, I'm planning to go and take up a PhD somewhere, but I'm not currently associated with any university at this point in time. I'm just digging around and scratching, and each intervention that I'm having on these STS sessions is actually helping me to see a bit more about spectroscopy and so on, because my practical side is lagging very much behind. So I do value all the time that the professional guys are putting in towards sharing for us. Thank you so much.
Thank you, Lisa.
So just FYI, Percy and Carlos are gonna try something to try to make the FCS error go away.
No problem, of course.
Read out.
Is that a big galaxy next to our PS1 RLR, or is that just reflected light? I'm looking at the TEL status.
Well, if it's a galaxy that bright, it would show up in net. So let me check net. So net is the NASA extragalactic database that lists most of the bright galaxies on the sky. We are at array of 0041.
Yes, 0041,
520. 20.37.
I seem to remember there's some kind of reflected light from some kind of glint from that part of LVM slit C, but I don't know.
No, I don't think.
No galaxy, huh?
I'm searching. I might be searching a bit. Increase my search radius.
What radius are you using?
I search around 1 arc minutes, but
yeah, that's way, because each slit is like, I think each slit is 20 arc seconds.
Okay, that looks like it. Yeah, that could be, yeah, it's probably just scattered.
So this next 5-minute exposure should be really strong, because the stars look good during this time. But this absorption line is so clear here, right?
Oh yeah.
This is from the 2 to 3 transition of the electron, level 2 to level 3 in the hydrogen atom. But in these pulsing stars, what happens is this Balmer line keeps changing. The velocity keeps changing. The shape keeps changing with time.
Exposure complete.
So let's see what this readout looks like. It's reading out. And please take it away, Carlos. And if you need to take away the thing, you might want to kill the script.
Should we pause this one? Yeah, they don't need to pause anything.
Oh, okay.
He just wants the mouse, basically. I think.
Oh, got you. I won't touch it. I won't touch it. It's all yours.
So you have it right now in the background. So
yeah, okay. Yeah, they just.
You can run the sequence in screen.
It's fine. It's fine. We're just reading. We're just running. Yeah, they just need to grab the mouse and Windows. Right. So there is no bright galaxy in the vicinity. So
I think it's scattered light.
Yeah.
DCD readout complete.
I will probably stop the recording now, if that's okay. Since we are